Okay, let's go over the midterm exam. Here's a copy. And so here's the first problem in case you can't remember it. Looking at, I give you this equation and I ask for you to solve for G, and I give you a value of L. Let's see, hold this camera steady here. I give you a value of L with uncertainty and a period. So the first thing to do is solve this equation for G, so I get this. If I square both sides and solve for G, I get that. And then you can put in your L and you can put in your T and you get a G value of this. Now, to get the uncertainty in G, we do the minimum G. So I'm going to put in the minimum L, but since I'm dividing by the period, I'm going to put in the maximum L, T. I'm sorry. If I do that, I get this value for the minimum gravitational field, or whatever you want to call it. And then I do the same thing for G max. I put in the maximum length and the minimum period, and I get that. And then to get the uncertainty, it's just max minus min over 2. Boom, boom, done. Next problem. Okay, ball launcher is shot with an initial, I give you the mass, but you should know from the lab that the mass doesn't matter. The velocity of 3.3 plus or minus 0.1, and the initial y. So this one's pretty straightforward. If you look at the x direction, the initial velocity is this. But we don't know the time. So the initial position 0, the final position is just v0t. In the y motion, I know the final y is 0, the initial y is given, the initial y velocity is 0, so I can solve for time right there. Now I'll plug that in up here, and I get this for the position. And plugging my numbers, I get that. Now I need to again do uncertainty, so I'm going to do the minimum position. So I'm going to put in the minimum position and the minimum velocity, and I get that. To find the maximum, I put in max, get that, and then just do max minus min over 2, boom. Position, boom, done. It didn't really matter how many decimal places you carry. Next problem. Okay, here's a ball that's shot straight up. Mass again. And I changed this. So I had a time to get to the highest point of 0.3 plus or minus 0.1 seconds. Okay, so here's the definition of acceleration: change in velocity over change in time. The final velocity is 0, it's at the highest point, and the initial velocity is your launch velocity, and the time is t. So my initial velocity is going to be negative gt. A lot of you put 1/2 in there. You're just memorizing an equation that didn't apply here, so you got to be very careful. 1/2 would be true if you had the time to go up and down, but that's not the case here. So you got to be careful about using equations where they don't go. So now all I have to do is put in the time, boom, boom, minimum time, maximum time, and then uncertainty is max minus min over 2. Boom. Last problem. Okay, here's a block, and it's being held up by a rope, and the question says, what's the tension? So here I have the normal force, here I have the gravitational force pulling down, and the tension, and there's no friction. Okay, so that angle theta is the same as that angle, and if I call this the x direction, then the net force has to be 0 because it's stationary. So I have 0 equals mg sine theta is the x component of that force minus the tension. So the tension is just going to be mg sine theta. There's m, there's sine theta, that's tension. That's it. Okay,